graph here may be a little tough to see. I tried to copy what I have on my screen from the classwork. You can definitely open up the classwork that's here as well and see what the graph's supposed to look like as I follow along. So what I'm looking for is what is the graph approaching in the y direction as I go towards a certain number in the x direction. That's really what it means to find a limit. What is the limit of y, the output, as x, the input, goes towards a certain number? So the first one asks me, what's the limit of f of x or y value as x approaches the value of -5? So if I look where -5 is on my graph, this is the x value of -5, this dotted line meant to represent an asymptote. When I look at it from this side, I'm going up towards positive infinity. When I look at it from this side, I'm going down towards negative infinity. The important thing here is they're not headed the same place. When something isn't headed the same place from the right side and the left side, that limit does not exist. I'm used to saying D, N, E for does not exist. In your book, I believe they want undefined. I know they say in the question text in WebAssign how they want it written. For my paper test, it would be DNE, but I think that you put it in as undefined when the limit doesn't exist. For the second one, it asks me, what's the limit of f of x as x approaches -1? Here I go to the x value -1. I look up to see where the y curve is. It's supposed to be at a darkened in point right here, basically showing me that the curve as I come from this side heads towards this point, which is x value -1, y value 7. Same thing if I head from this side on the curve, it's also headed towards that darkened in point at -1, 7. So as the x value gets closer to -1, the y value gets closer to 7. That's why the limit of f of x as x approaches -1 is 7. For question 3 here, what's the limit of f of x as x approaches 0? Here's where x approaches 0. It's where it crosses the axis. You're coming down towards what should be 0, 5. Same thing's being approached here. Even though it's not a darkened in point, I can look at where it's crossing and see where it's happening. I don't need it to be a special identified point on the graph. I could find the limit towards any x value I wanted on this graph, especially if I had a graphing calculator where I could put in that I wanted a specific point. But in this case, I tried to make it clear that it crosses here at a y value of 5, which is why my limit as x approaches 0 of f of x is 5. When I look at this final one for this graph, the limit of f of x as x approaches 3, what that's saying is I want to trace it as I go towards an x value of 3. At that x value of 3, I'm headed towards this open circle, which is a y value of 3. This is an important distinction. Here, when I was headed towards a filled-in circle, if you'd asked me, what is f of -1, the answer would have been the same as a limit, which would have been the y value of 7. Since it's a darkened circle, not only is the limit as I approach -1, 7, but also the actual value at that x value of -1 is 7. As opposed to this situation, as I'm getting closer to an x value of 3, from both sides I approach the same y value, specifically this y value of 3. So the limit does exist, and as x approaches 3, y also approaches 3. But the difference is, if I were to ask you what's f of 3, what does the curve equal at this value of 3? It does not exist. There's a hole there. The graph isn't there. So even though it approaches the same thing from both sides, it doesn't actually get there, which can happen in real life. We're going to see examples in further along in this unit where we have what's called jump discontinuities. So it's not just a conceptual thing here. This can happen where a limit exists, we're headed the same place from both sides, but the point itself does not exist. Here's an example of where that happens. If I want to find the limit as x approaches 2, or as x approaches -2 of x plus 2 over x squared minus 4, What's really going to happen if I just plug the number in is I'm going to get negative 2 plus 2, which equals 0, over negative 2 squared, which equals 4, minus 4, which also equals 0. I get 0 over 0, which is called the indeterminate case. I don't know what's going on. I have two hard rules. 0 divided by anything is 0, and when you divide anything by 0, it does not exist. I don't know what's happening. When I get the indeterminate case by just plugging a number in, I have to investigate further. So really, we're trying to see in situations like this, what happens if we just brute force it? Brute force it means plug in these numbers that are close to the offending number, but not actually the offending number. So I'm going to plug in on top, parentheses, negative 2.1 plus 2, and parentheses, divided by parentheses, negative 2, and parentheses, negative 2.1, and parentheses squared, minus 4, and parentheses. When I put in enter, it gives me an answer of negative 0.24. Let me just make sure that I did that right. Negative 2.1 plus 2, and then I did negative 2.1 squared minus 4. Okay, so let's now try 2.01. So if I make that 2.01 instead of 2.1, now I get negative 0.249. If I do it again to where now I'm doing negative 2.001. Now I get negative 0.2499. Basically, you would see that it keeps getting closer and closer, but not actually hitting negative 0.25. That's what the limit's approaching. That's what the answer to this question is going to be. The limit equals negative 0.25. I can see it from the other side by putting in negative 1.999. So if I do that, at negative 1.999, negative 1.999, it gives me negative 0.250065. If I get rid of one of those 9s and now just make it 0.99, it gives me negative 0.2506. If I were to do it again, it would give me negative 0.2565. Basically what you see is, as I get further from 2, it gets further from my limit, but the closer I get, and if I kept going out more and more decimals, this would get really close to negative 0.25. This would get really close to negative 0.25 without actually getting there. This is the correct answer to this question. So really the end of this homework is just asking you to brute force it. Use your calculator, find it however many decimal places they're asking for, just to kind of establish that we could find answers this way, so that when we learn the mathematical way to actually find this without brute forcing it, you can say, all right, if I wasn't sure if this was right, if these methods work, I could check by looking at it like this.